Okay, Company B. Let's start with Company B. Starts at 75,000 starting salary. Is that right? How does the salary change year after year? So if I've got 75,000, what's that? He wants plus 1,500. I said ignore that. Just ignore the 5 years thing. So so we're adding to what? The output or the input? To get the next output. All right, so what's the salary after 1 year? It has to be 75,000 plus 1,500, right? 76.5. Next year. We're going to take the one from before, equals the previous year, and add 1,500. So how is the salary changing? How is the salary changing?
It's increasing by 1,500 every year.
Increasing by 1,500 every year. So increase by a certain amount is what operation?
Addition.
So addition, right? This is what we call additive growth. Every time a year goes by, we add a value to the output to get the next output. Additive growth, okay? And what kind of, and we said that's what, constant rate of change, right? Because every time x changes by the same amount, an equal amount, we get a consistent change in y. That's what we said, it was constant rate of change. So we have another way of thinking about constant rate of change now as it's an additive type of growth. You keep adding the same value over and over again. Every time one unit of input goes by, you add the same amount to get the new output. Okay? What about the salary of Company A? So what's the scheme? A 5% increase, right? So I'm going to take 5% of 66,000, and that's going to get me my next year's salary. Is that right? What does that give me? That's an important number. What is it? The increase, right? That's the change. It's increasing by that much. So to get the next year's salary, we can just take the last year's salary and add the increase. And so we did this last time. It's definitely worth doing again. We can factor out the 66,000, and what's left? 1 plus, this is really important, 0.05, which is 1.05. But when you look at that 1.05, it's really important to see it this way. So we're going to call that amount of increase. So what you see is, oh, there's the one from the previous amount, holding on to the previous amount, and increasing by this fraction of the original amount, or 5%. So this idea of that and what did we call 1.05? The growth factor, okay? So this is what exponential growth is. Multiplying repeatedly by the same number, which we call the growth factor. Multiplying repeatedly by the same number, which we call the growth factor. Okay, so I'm going to take that 66,000. To get next year's salary, I'm going to multiply it by what? 1.05. The 1 keeps the previous year's 66,000. The 0.05 is the increase. So it does it all at once. With that one multiplication of that one number, it does it all. So these are dollars, so we want, there we go, dollars and cents. Perfect. Okay, so what about after 15 years? Fernando, after 15 years, how can we, I don't want the final answer, I want the process that you would go through in order to get this salary after 15 years.
Okay. So what you do is you would originally take the
66,000.
that you started out with.
Yep.
Multiplied by the 1 plus 0.05 because the
Okay.
1 hold on to the
Can I just do 1.05?
Yes.
And multiply by 1.05?
And well, you would raise that to the power of, in this case, the 15 years.
And what does that accomplish? Why are we raising it to the 15th power? What does that accomplish?
Because you're multiplying that 1.05 over and over and over and over.
How many times?
15 times.
15 times. You see what he said? He said I'm multiplying by the 1.05 over and over and over again. And so in 15 years, you're going to multiply it by it 15 times. So that's what that 1.05 to the 15th means. The main thing going on there is repeated multiplication. After 15 years, you will have multiplied by 1.05. So I think we're looking at 6 figures here. Oh yeah, right? 137.2. Question?
Oh, I was for the equations itself. I was with the equation.
Okay, I'm gonna go. So this is the 66,000 times 1.05 to the 15th. Meaning, multiply the 66 by that 15, that 1.05, 15 times, once for each year. Okay, so now n, how about somebody new? So how would we then come up with what it would be after n years? Somebody new. Where is Dustin? Yeah. So how would I get the
66,000
okay?
times 1.05 to the n power.
And what does it mean? Can you explain it?
So it's 66,000, which is your starting salary, times the growth rate, n times.
Times the growth rate n times, because it'll be once a year for n years. Every year times that 1.05. Okay, so this is giving us a general form of an exponential function. This is, so if we had f of x, so we're going to take the company A. You read? So company A. We can make it into a function. X is the number of years after hire. And so we'll start with the initial value. And we'll keep, for every year that goes by, we'll multiply it by 1.05, which has the effect of increasing by 5%. And so after X years, how many times will we have multiplied by 1.05? After X years, how many times? X times. That's our exponent. That's what it means. The number of times we multiply by 1.05. Question?
If you wish to, for example, get a pay raise more than just once a year,
Okay?
could it be done so that it's 66,000 times 1 plus 0.05, and then the 0.05 over however many times per year, to the power of however many times per year times however many years.
It sounds like you're talking about compound interest or something like that. Yeah, we're getting there. We're getting there. Yeah. Okay, so let's do a general form then for exponential. We said that exponential growth is a very specific kind of mathematical growth. It doesn't just mean whirling off really fast, right? So that's how the world uses that terminology. It's growing exponentially. All they're saying is it's just growing really fast. Okay? So what about this? Is this growing really fast? I mean, it's nice after 15 years, you've doubled your salary, but at the beginning, is it growing exponentially the way the world uses that term? No, okay? 5% is just a little bit of an increase, right? Now that builds up over time. But exponential growth is specifically, mathematically, it's this type of growth where you have a growth factor, which we call B. So B is the growth factor, and then you have an initial value, and you keep multiplying that initial value by the growth factor. Over and over and over again. If the mathematics is different than that, it's not an exponential function. There's a million ways to make a curve mathematically. This is one particular way, by taking an initial value and taking a multiplier called the growth factor, just multiplying it over and over again. That's specifically what exponential growth is. Michelle? We're doing that next. We're doing that next, yep. Okay, so this B we want to write as 1 plus P, because the B is the multiplier, and the P represents the, what does it represent? The increase or the percent change. So that's the growth factor is the multiplier, and the P is the percent increase. So we want to think of that B value as keeping what you had before plus the amount of increase, P. And then your A is your initial value. So there's our general form. That's the mathematics behind exponential growth. I think the table is the best way to create an image of it. Every time you advance an output, you've multiplied by this number to get the next one. That value B, the growth factor. Okay. Any questions? I'm going to erase and move on to something else. Any questions about all this? Actually, before we do that, so let's say, how would you figure out how many years it would take to reach a salary of, say, let's say 100,000? Or let's say 200,000, okay? So how many years to reach a salary of 200,000? So at this point, we're going to need some kind of like either keep working on the table or make a graph, okay? So there's an algebraic way to do it, but we get to that in a week or two, all right? So at this point, we're gonna do it by a graph, okay? So can I erase what's up there? The writing. Here we go. Okay. So let's do it by graph here. So we got, what's our function? Y equals 66,000, 1.05 to the x. Okay, so I'm going to graph that. And my scale doesn't show anything. I've got to look at zooming out on that y-axis so we can see values in the thousands. I could have done in thousands too. Absolutely. All right, and we also want just for x greater than 0. What just happened there? That's not what I wanted. There we go. Okay. So, is it growing exponentially? Yes, it is. Why? Because it has this form of repeated multiplication by the growth factor. So what did I say? 200,000? So how would we find when the salary reaches 200,000? Using the graph. Omar.
We see when it is 200.
When what is 200?
The number of 2,000. The number of money is 200,000.
And which coordinate is that? Which coordinate is that? Horizontal coordinate is 200,000?
Yeah.
Yeah, so
Like this way?
that's our y coordinate, right?
Yeah.
So we want y to be what?
When y hits 200, we see what does it hit with x, then x would be the number.
Yeah, so when you're looking at a graph, good. So yeah, when you're looking at a graph, you got to know what your quantities are that you're graphing. The x quantity is?
200.
Not 200. The x quantity is the number of years after hire. That's the input. And the output is? No, just what quantity is it?
Money.
Salary in dollars. Annual salary in dollars. Okay, so we gotta have, so before you analyze and start going for numbers, really make sure that you're 100% clear what do our two axes represent. Okay, and so I've got this is 200,000 and here's our actual salary growing here. So I'm gonna come here and I'm gonna look at, and you can do this on your graphing calculator. So now I've got this point where 200 meets that graph. So what, and right here it tells me my ordered pair. It's pretty small, but the X value says 22.7 and the Y value says 200,000. Question?
In our homework, where it asks us like an example like this, of how many years we take this 22.7, or can we put between 22 and 23, or on the
So you have to think about the specific situation. Every situation is different. Now this is talking about a salary. So when do you get your raise continually throughout the year? No, the implication of this problem is that at the end of the year you get this 5% jump. So how many years does it take to reach 200,000? 23, because actually at 22 you're going to be a little bit less than that. 23 is then you've surpassed 200,000. Okay? Questions on that? So whenever you have a question about, what's your X quantity, what's your input quantity corresponding to an output quantity, use the graph. Use your graphing calculator and do it this way with a graph. And then later we'll find a way to do it algebraically. Okay? Any questions on that? Okay. So, Michelle asked a good question. Look at number 9 on page 165. This is different, and this gets trickier now. This gets trickier. What's the initial mass? 203? Thank you. Micro or milli? Oh, I don't know how to do micro. Oh, look at that. Found it. Cool. So what's different about this one? Decay, decrease. So how much is it decreasing? 12%. So I'm going to take 203 times 0.12. Does that give me the mass after 1 hour? He said no. Why not?
It gives you how much mass decreased.
He says it gives you how much the mass decreased. Okay? What is the output of our function? The output of our function, is that the quantity that's the output of our function? Yeah, right. Exactly. So Troy said you want to, so what do you want to, how do you want to do it, Troy?
Well, you need to do it 203 minus 23 times 0.5.
That's how I want to do it right now.
Okay.
Okay, that's how I want to do it, yeah. So if you start it and then you decrease by that much, that would be 12% of 203, right? Okay? So we're going to do the same process again. Look, what am I going to do? Remember this? Factor out 203. Okay, and so what happens? 203 times 0.88. So a decrease of 12% is the same as multiplying by 0.88. Do you agree? So what does the 0.88 represent in this problem? What is this number? It's the decay factor, but what does it do? What does it mean? 0.88.
88% of the original amount of bacteria.
And what happens to the 88% of the original amount? So we lose?
That's the amount that it becomes with each time.
Right, it's the amount that we keep. So the decay factor gives you the percent or the fraction that we keep in moving on to the next output value. That's key. All right, so that, and it comes from the number 1 minus how much we lose, right? How much we lose is 12%. So a decay factor is the fraction. It's just like a growth factor, but now it's going to be a fraction, right? And it's going to be the fraction that we keep. That's what the decay factor is. All right, so I'm going to come here and I'm going to do 203, the one above, times 0.88. So do you see that by multiplying by 0.88, that is finding the new amount when we decrease by 12%. That's finding the new amount when we decrease by 12%. There it is. Okay, and so I can just pull this down. And so where did this say after 7? Tell me, where does that number after 7 hours come from? Can you summarize where the mass of bacteria after 7 hours, where does that number come from? Somebody new? You want to explain where that number comes from? Frank? 203. He wants 203 times 0.88 to the 7th power. Agree with that? Is it Morgan? And what does that mean? So that calculation that he just wrote out, can you explain what it means?
So since it loses 12% each hour,
Yep.
each hour it maintains 88%.
Right?
So after 7 hours, it's maintained 88%. The 7th hour because it's going to be 88% times 7 times.
7 times.
And then that's times the original amount, which is 200.
Yeah. So exactly. So you start with 203. By the time 7 hours is rolled around, how many times have we taken 88% of it? 7 times. We take that fraction 0.88 of it. It means multiply by 0.88 every hour for 7 hours. That's what the exponent means. Okay. So now let's write the function. So we want after x hours. After x hours, how would you get it? What's that? 203
times 0.88.
How many times do we multiply by 0.88 at x after x hours? X times. So you gotta imagine that as 203 times 0.88 times 0.88 times 0.88 times 0.88. How many times? However many hours you want to know what the mass is, right? However many hours you want to know what the mass is. Okay, so there it is again. There's our form. Initial value in this time, 203. Growth factor. Now it's called the decay factor. What's our multiplier? Our multiplier is 0.88, which represents what decrease? Yep, it represents so we can rewrite it as 1 minus the decrease. So when you have increase, what do you know about your value of B if it's increase? What's that? It's over 1, because you'll have the 1 plus the increase. What about when it's decay? Below 1, it's a fraction of 1, because you're always keeping a fraction of what you had before. Jonathan, sorry.
I just want to know if you're recording.
Oh yeah, I am. Yeah, see that my icon up there, the red? So if you ever see that red and it's not on, then yeah, tell me. We'll get it going. Okay. Cool. So any questions so far? So decay is trickier because it's hard to see. Maybe if you've got a decay factor, it's hard to instantly see what what the percent change is. Okay, it's easier to see it with with increase. Now but remember when we had the last time, the number of cells, right? It was 7, the initial was 7, and it quadrupled. Every hour it split into 4. So what was our growth factor for that? Our growth factor was 4, right? Because it's multiplying by 4. So what's the percent increase? It's a harder question. You really got to know your stuff. What's the percent increase? Talk to the person next to you. See if you can, what is the percent increase when the growth factor is 4? Talk to the person next to you. See if you can get it. Who's smart? Who thinks they got it? What do you think? 400%. Is that what you think? Something else. 300%. Any other candidates? Was that? 157%. We got all kinds of ideas here. Yeah. 37%? 57%. Okay? So let's talk about, if it was 57% increase, what would B be? If it was 57% increase, it'd be 1.57. That would be 57% increase. What about 99% increase? That's 9. Do you see that's 99% increase? So what is 2? What if we're doubling? If we're doubling, what's the percent increase if we're doubling? 200%? See, it's harder. So it's right. So if B is 2, you got to see it as 1 plus 1. What's your percent increase? 100%. See, look, if 1.99 is a 99% increase, then 2 is a 100% increase. You have what you had before, and you doubled it. So the amount of increase was the same amount that you started with. I see like a glazed look. Does it make sense? So what about 4? What the growth factor is 4? What's the percent increase? 300%. So this, you got it back here. So 4, you got to see it this way. 1 plus 3. What you had before, the amount of increase is 300%. Okay? So don't be a victim on the exam. Don't be a victim on the exam. So there's a question like this on the exam, and it's like 25% success. So get that right. Get it right. See growth factors as 1 plus a number. If you see it as 1 plus a number, that number is your percent change. Does it make sense? Do you see that doubling is 100% increase? That should make sense to you. If it doesn't, then have a conversation with someone to hammer that out, okay? Whether it be me or Roy or somebody. Doubling is 100% increase. Okay, so look at the ones on page. Turn the page and look at 11B. Oh, it's the same. No, don't forget that. They're the same. So what I want you to do is go to all the way back to investigation 3, which is on page 135.
Remember we were asking in terms of what is the growth factor for every 6 months? That would be different than the growth factor for every 1 year. Right. And so we're saying is it's for 1 year X because we know the units on X. It's what's the multiplicative change amount of X to X plus 1.
that is additive. The initial value. The growth factor is not. The growth factor is 1.19 completely. But the 19% is what's taking out the initial values and added to the initial values.
Those are the chances, and because we aren't later on in this last part, what's the half or something like that, we're looking to less than the growth. But at least at this point, it's the exact same.
Okay, check number 2. Keep working. Check number 2, though. Check number 2. Are we on the same page? Do you get it? Check number 2. So initial value, that's easy.
Yes. So.
Which one is the multiplier? The 0.68 or the 0.32? What is the multiplier?
0.68.
Look at the formula. It's telling us to take that initial and multiply it by what? 0.68. P times. P times. The multiplier is 0.68. And that's the amount we lose or the amount we keep? It's how much, the decay factor is how much we keep. It's the fraction that we keep. Right? And so here's, and then that percent change is figuring out how much you lose. So it's from whatever that amount is from 0.68 up to 1. Whatever that amount is from 0.68 up to 1. That's how much we're losing. And that's 32%. Questions on number 2? Are we good? Yeah.
What I've been realizing is couldn't you just based on the amount of keys figure out that the 32% because since our out of 100 is
Right. Yeah, I did over here. So I did. So you're saying 100 minus 68.
yeah.
Yeah, so I did 1 minus 0.68. But I actually like that better. I like that. Yeah, I like that. 100 minus 68 equals 32. And so then 0.68 is 1 minus 0.32. Okay, 3 or 4. So we talk about either numbers 3 or 4. I heard both. Yeah, is there a typo in your book too on number 4? Because it's saying decay on here. No, so that's just a typo here. What was the question, Jackson?
No.
Okay. So I heard 4. No? Yeah, I heard both, but let's do 4. So now we're just given the values when we have to figure out the growth factors. So if you know what the growth factor is, you can do it. What does the growth factor mean? What does it do? What does it mean? Somebody new. Callaway. Where's Callaway? Callaway. Take your headphones out. What does the growth factor mean? So if we want to figure out the growth factor from this data, we start with the meaning of it. So what does it mean, the growth factor? Okay, so mathematically then, how do we do that? You're saying how much is growing, that's true, but mathematically, what is it? How does it work, the growth factor? Well, no, that's the value after 1 unit. So how are we going to get the growth factor out of this?
299 minus 260.
You're going to do minus. So 39. Is that the growth factor? So that would be like additive growth, right? You're figuring out how much you would add. But what is it based on? Multiplication. So the growth factor is like, if you started with 1, what would you do to get to the next? You would multiply, we're going to get to B, right? So this is the idea of it. You've got this number 299. If you were to multiply by the growth factor, which we don't know, you would get the next one. You see? So that becomes 299 times B equals, this is a really, really helpful skill, what I just did in solving a lot of problems. You don't know what the growth factor is, but you know that if you multiplied it by 299, you would get the next output, right? So you can pick any one of those if you know that it's exponential growth. So now we just need to figure out, how do we figure out what B is? You're going to divide 343.85 over 299. We're asking what number multiplied by 299 gives 343.85? That's the number that if you multiplied it by 299, it would give you 343.85. What do you get? 1 point? Exactly 1.5? Easy one, percent change. You can just see it. 15%. Okay, now initial value. How can we use the same thinking to find the initial value? So how can you use the same thinking right here to find the initial value?
Would you subtract 0.15 to make it like if you're trying to make it decrease like a decaying value, so it would be 260 times 0.85?
Close, but that doesn't work actually. It doesn't work. So let's call it A, right? The initial value we called A. And so what's the relationship between A and the growth factor and these numbers up here? Omar.
A equals 299 times 1.50.
No, so A is back here. All right, hold on a sec. So A is back here. So how does A, yeah.
We divide
Divide what?
by 260.
By? That's right. So if we took A, how would we get 260 from A? You'd multiply it by 1.15. If you took A and multiplied it by the growth factor, it would give you? It would give you 260. Do you see that? So there's that thinking again. You got the starting value. If you multiply by the growth factor, it will give you the next value. So what she said is correct. It's going to be 260 instead of times 1.15. You're going backwards, so you're going to divide by 1.15, which is different than multiplying by 0.85. You'll get a different answer. What's the initial value? 0.9? Okay, if I add problems, I'll send out an email. If you don't get an email from me, we'll just check regardless. But if I add problems, I will send an email. Have a good weekend. Yeah, recitation today. Yep.
I have a question just to make sure that I'm doing this right.
I did. I'm learning people, so I'm not calling names. Hi, Tanner.
I just was wondering if I was doing this, if I did this right, specifically this one.
No. So what does the 1.19 mean?
Well, I tried following it by this.
Is it?
Because I know that but if